So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about advanced part modeling techniques in Onshape. And this webinar is really intended for those that maybe have attended the Essentials webinar and understand the fundamentals, the basics of sketching and simple feature creation, but are trying to dig in a little bit more. Want to cover commands like revolve, sweep, loft, patterns, variables, all the things that you might use to really build a robust part in Onshape. So some of the more advanced part modeling techniques, and of course, when I say advanced, I mean things that we don't get to cover in the Essentials webinar. Now, as I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions dialog in your GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and address the questions as we're going through today's webinar. Now, as I mentioned before, this webinar is really intended for those that are just digging into Onshape and want to understand some of the more advanced part modeling techniques, things like revolve, sweep, loft, shell, and so on. Now, before I get into the topic of the day, there are always a few things I like to mention about Onshape in general. So if you're new to Onshape, one of the biggest things I always like to mention is our mission statement, our goal with Onshape, and that is getting everyone working together with CAD on any device, anywhere. And this includes mobile devices. So if you haven't downloaded the Onshape app for iOS or Android, definitely recommend that you do so. It's a real full CAD editing tool. It's not just a viewer or a markup tool. You can create sketches, features, parts, assemblies on your phone or on your tablet. But this also means any device, Windows, Mac, Linux, Chromebooks. So you really do have accessibility from just about anywhere. Now, the other element of this is working together, working collaboratively. And that's a big part of how we differentiate ourselves from a lot of what you see in traditional CAD applications is the fact that we can work together simultaneously on the same model, and everything updates for everyone in real time. So everyone working together with CAD on any device, anywhere. That's our goal with Onshape. Now, the other thing I always like to mention is we do consider ourselves professional 3D CAD. And when you think of professional 3D CAD, you think of parts, assemblies, and of course drawings. And we do have parts, assemblies, and drawings, of course. But we have a lot of things that you don't get in more traditional professional 3D CAD systems. So, for example, in a more professional 3D CAD, traditional professional 3D CAD system, you would have, once a year updates with maybe service packs for bug fixes a few times a year. In Onshape, we update roughly every 3 weeks. So we update frequently, much more frequently than any other professional 3D CAD system out there, and it allows us to really evolve quickly and iterate fast. So frequent updates with Onshape, also built-in version control. So in Onshape, you have the ability to capture a milestone in your design and come back to that. And that's something that's typically reserved for more expensive product data management systems and other professional CAD systems. This is something that's built into Onshape's core. Question: how do I ask a question to the presenter of the webinar? You just did, so feel free. Any questions you have, ask them in the questions section of the GoToWebinar control panel. So built-in version control, again, you can capture that milestone. Maybe it's a revision in your design. Maybe you just have a certain point that you always want to go back to. You can do that. In Onshape, we have that ability, and it's built into Onshape. It's not something that you have to purchase or manage separately. Now, also comes with Onshape the ability to import and export common CAD formats. So if you have a library of CAD data in other systems, maybe you've come from SolidWorks, you've come from Inventor or Creo, whatever it may be, and you have this library of data that you've built up over the years, you can work with that data in Onshape. You can import those files into Onshape. You can even manipulate them with direct editing commands, and we can even export to a lot of these formats as well. So it means that Onshape works well with your CAD library. It works well alongside other CAD systems as a tool, maybe for collaboration or for working with vendors. So there's lots of good examples of that. But the key thing is Onshape can import and export a lot of those common CAD formats that are out there. Now, the next thing I want to mention, I've already briefly mentioned it, but with Onshape, we've introduced entirely new methods of collaboration, something you simply can't do in any other professional 3D CAD system, and that is collaborate with others in real time on the same model. In a traditional file-based system, you would be sending files back and forth, maybe emailing copies of files back and forth if you want to work with someone on a design. In Onshape, you can literally share the same model and work on the same model at the same time. Any changes made by anyone, update for everyone in real time. So there's no save, there's no check-in, there's no merge, none of those types of things exist in Onshape. It's real-time collaboration between users. So if you haven't shared your document yet, I definitely recommend it. It's one of the biggest benefits of Onshape is just the fact that you have that real-time update, and you're always aware of the latest. Now, the last thing I want to mention, and it's a big one, if you're interested in if you've ever done any kind of programming, you're interested in writing your own custom CAD feature, with Onshape you can. We provide a language called Feature Script that allows you to build your own custom CAD features, and really unique to Onshape, and it's something that really gives our users a lot of power. You can build, simple things that you do often, maybe tedious tasks that you want to simplify. You can even add things to the Onshape commands. We publicly release the source code for Onshape's standard extrude, revolve, all the Part Studio commands, and you can even take a copy of that and build your own variation of that command. So the big thing I want to stress is, if you're at all familiar with programming and you're interested in writing your own CAD feature, you can do that in Onshape, and you can truly customize how Onshape behaves with Feature Script. Questions. I'm struggling with mate orientation. That is the turn the primary direction after I've called for a mate. Which webinar covers this technique? The assemblies webinar. I would recommend, if you do a search on YouTube, you'll find assemblies, many different assembly webinars for Onshape. And a tip, by the way, this is just in general. We have a playlist of past webinar recordings on our YouTube channel. I think there's close to 90 different webinars there, all kinds of different topics. What if there's no internet connection? Is there a way to look at models or drawings that if they're prepared before no internet connection? No. It's important to point out Onshape requires internet. If you can't check your email, you won't be able to access Onshape. Now, we work fine on 3G and 4G connections, but if you have no service whatsoever, no internet at all, then no, you will not be able to access your Onshape data. Question. I'm a beginner in CAD and I only have a little bit of experience with SketchUp. But I can tell Onshape is really great. I would recommend, if you're getting started, we have webinars on our YouTube channel like Sketch Basics and Essentials, and those are really good webinars to get you started. These are going to be a little bit more advanced if you're brand new to CAD. Regarding collaboration, does follow mode allow view only to follow a user editing a private document? No. View only does not allow, follow mode is not allowed in view only circumstances. So it's only when the person you're sharing with has edit permissions. All right, so what are we going to talk about here today? Well, as I mentioned before, we're really going to get into the things that we didn't have an opportunity to get into in our Essentials webinar. So, in the Essentials, we discussed the basics of starting a sketch and some of the basics of sketching and creating a simple extrude. But what about all the other commands? Sweep, revolve, loft, hole, shell, derived, all the different things that we have in the toolbar that a user is going to need to build their complex parts. So let's get into those. Now, as I mentioned, I'm going to start with sweep and revolve, then we're going to get into loft. Hole feature is a big one if you're trying to create counterbores, countersinks, those kinds of things. Shell, obviously a very important command. And then we get into derived feature when we start talking about multi-part modeling and the need to model parts with contextual relationships to one another. I'll give you an example of all these in just a second, and then we're going to end on patterns and variables. Question. I am doing a simple bearing that I want to use in multiple places. What is the best way to do that? If you're referring to the organization of it, I would put the bearing in its own document, reference it, you can version it, and then insert that bearing anywhere you want. So I would say, having it as a separate document, if your bearing, quote unquote, is a library part that's used in many different places, a lot of users will create a document of library parts that they can use in all the different places they may need them. All right, so enough slides. Let's get into it. Now, as I mentioned before, I'm going to start with the sweep and revolve command, and then we're going to get into the loft command. So let's start with revolve. Now, the key thing to keep in mind with revolve is you're creating round parts. If you need a round part, the revolve command is, of course, the tool that you can use to get a very quick round part, and in particular, a complex round part. So if I'm looking at something like this part that you're seeing in front of you, You can see it's a round part with several different profiles here. And yes, you could create this using a combination of extrude features and cuts and so on. It's much easier to do this with one revolve feature. Okay, so this one sketch, one feature is what makes this part, and we're revolving that profile to create a round part. And that's the best way I can describe it. If you take your sketch and rotate it to create a solid part, that's what Revolve is doing. And I'll show you an example of this in just a second, but here's a simple example of a part you might create using Revolve. Now, another example is, of course, sweep. And the key difference with a sweep is it requires two things. It requires not just a single sketch, but two different, oftentimes two different sketches, a profile and a path. And what you're doing, like the name implies, is you're sweeping a profile along a path to create a shape. A good example of this would be like a U-bolt that you're seeing in front of you. But any type of shape that you need to sweep a profile along a path, that's your sweep command. So let's get into an example of creating these. I'm going to start with the revolve command. I'm just going to start a sketch on the front plane. Now, as I mentioned before, you have to think of this as taking that sketch profile and rotating it to create a 3D part, right? So we have to think of what is that slice section of the part going to look like. And if we were to model something like that pulley example that I showed you a moment ago, one of the biggest tips that I can give, and it's just a general best practice, I don't know that I would say it's a rule, but it's just in general, I always like to start with what is my rotation axis for this revolve? You know, what am I going to be rotating about, especially when I'm starting with nothing like I am here? And so one of my first tips is, to draw in that revolve axis, right? So I'll select line, construction line, and just draw a horizontal line right through the origin. All I'm really doing here is saying this is the axis I'm going to rotate my revolve around, right? That's, in general, one of my first steps when creating a revolve. Now I can just sketch my revolve profile. And again, I'm just sketching that slice section of the finished part, right? All right, so a few tips that I have. This is a general sketch tip, but you'll notice there will be times when you want to create some kind of a reference to something that's not popping up automatically. An example, I'm drawing this line, this vertical line. I want it to be the same exact length as the line to the right of it. But as you can see, as I move this, I'm not getting that reference to the point on the right. A tip, and this is just a general sketch tip, not specific to Revolve, if you move your cursor over any point, like this one, it will wake up the reference. So now as I move back, see it appears now, right? So we call that waking up the reference, but essentially all you're doing is moving your cursor over a point and then moving it back, and what it does is it wakes up the reference to that point so that you can easily create your constraint relative to it. Another good example, I want this line to end vertical of this bottom, the point below it. Again, move my cursor over the point, wake it up, move it back, and now I have that reference. The big thing there is, of course, I then don't have to go back and manually constrain things, right? I don't have to go in and manually add constraints. I'm just waking up those constraints as I'm sketching. Now, another thing that I want to do here is I want to center my revolve profile over the origin. And another tip is it's easy to create a symmetric constraint around a vertical center line, right? So let's sketch a line vertical like so. And what I want to do here is create a symmetric constraint between these points so that it's centered about that construction line. Now, the question often gets asked, could you use mirror? And yes, you could. I could have sketched half of this and mirrored it to the other side. But if you've done like I've done here and sketched everything, it's easy to come in and add symmetric constraints, right? So left click the construction line, left click the third point, and we'll say they are symmetric. Now you may ask, why is that important? Now this is centered, and if I change the width of this, it remains centered over that construction line. Right? So it just gives me that symmetry that I'd expect. So again, left click, symmetric. I'll go through and define these symmetric relationships, and now I get that symmetry I'd expect when I go to change my dimensions. Now, that's the next step for me. I've sketched my closed profile that I want to revolve, but I haven't added any dimensions to define its size. So let's do that. I'm going to add a width dimension here. Let's say that this is 4.5. And a width dimension here. Let's say this is 2.75. And a width dimension here. Let's say this is 0.75. All right, so I've added all the width dimensions. The next step that you're going to do is you're going to say, well, I want to add a dimension from here to here. The problem with this is, remember, this is a round part. We're going to take this and rotate it to create a round part. And chances are, in many situations, not all, but in many situations, this dimension is going to be a radius value. It doesn't really help you define, diameter values. If I'm building a round part, I want to define using diameter values, not radius values. And essentially, this is a radius value if you think about the end result here. So a tip is, if you've constructed your Revolve profile similar to how I've done here with a construction line, you can move your cursor past that construction line, and it will double the value and add a diameter symbol. This is especially important for Revolve sketches like this, because now I can define my sketch using real diameter values and not radius. I'm not cutting everything in half just to figure out what the value should be. Right? So it's easy for me to come in, define about this construction line, again, move past the construction line, it doubles the value, and now I'm off and running, adding real diameter dimensions and not radius values. Okay, so a big tip, and this is particularly important in Revolve sketches like this, if you dimension relative to a construction line like this, if you move past it, it will automatically double the value and add that diameter symbol, implying that this is a diameter dimension. So a big one, if you're constructing a lot of Revolve profiles, you'll probably want to dimension that way. As I said, not all scenarios, but most you'd want to dimension in diameter. Okay, so a few questions. Which one point was major for symmetry? Forgive me if I'm not sure I totally understand. I think if you're referring to what is the center for symmetry, that is the construction line, right? So you'll notice in the symmetry constraint, I went point, construction line, point, in that order. And this is because the center, in this case, a vertical construction line, is what I want to say is the middle, right? Is what I want my symmetry to be about, so to speak. So in this case, that was the vertical construction line that I sketched from the origin. That just maintains that centered or symmetric relationship about the origin. Question, how do I duplicate a separate mirror image of the part already created? If you're just referring to a mirror of sketch geometry, there's a few different mirror commands in Onshape, but you have a mirror. So you select mirror, you click on the line that you want to mirror, and then click on the entities that you want to mirror. It mirrors it to the other side. So just keep in mind, I showed you symmetric. Symmetric works great, but you can also sketch half of this and mirror it. If you're referring to mirroring an entire part or mirroring an entire feature, those are feature level mirrors, and that's not at the sketch level. Different thing. Question. Sorry I missed this part. How can you make the sketch define the whole diameter dimension? So the key to that, the only thing you missed is make sure to dimension about a construction line, move your cursor past that construction line, and it will double the dimension and give you that diameter. So you don't have to dimension radiuses. I think that's just confusing. It's hard for design intent. If someone else opens this up, it's going to look weird, right? So I think for most users out there, if you're creating a full round part, just keep in mind, you want to dimension with diameters. Question, is this an advanced modeling class or just modeling? As I mentioned before, this is intended for those that are just getting started with Onshape. If that's not you, this is definitely not for you. What I wanted to focus on was the things that we don't cover in Essentials. In our Essentials webinar, we cover the basics of sketching and extrude, but we don't get into Revolve, Sweep, Loft, and so on. So that's what we're covering here today: Revolve, Sweep, Loft, patterns, variables, and so on. All right, so this is a simple Revolve profile. The next step for me is, of course, to revolve it, right? So I've finished my sketch. I'm going to go straight to the Revolve command, so I don't have to exit the sketch first. And so I click Revolve. It will automatically select the sketch because, of course, That's what's highlighted. That's what I was in at that time. But you'll notice there's one more thing for me to do, and that is define my Revolve Axis. As I mentioned before, oftentimes, especially in a scenario like this when I'm starting from scratch, I like to start with the Revolve Axis. It just makes it easy to define. But essentially, just think of this as, what are you rotating this sketch profile around to create a round part? In this case, it's the very first construction line that I sketched. Right? So I'm going to click in the Revolve Axis box in the dialog, then just left click that Revolve Axis. It will then take the profile that I've sketched and rotate it all the way around to create a round part. Okay, so let's get into now. The thing that I wanted to mention is, by default, it assumes that you want to rotate a full 360 degrees, right? So you do have some options here I do want to stress. So one direction, symmetric, and two directions. As the name implies, these are not full 360 degree revolves. These are a certain amount of rotation, right? So I can say revolve 45 degrees, right? So not a full revolve, only 45 degrees. I can say symmetric 45 degrees. Right? So it's splitting it and going both directions. And I can also say two directions, 45 this way, 330 this way, and so on. Right? All right, so let's get into it. Now, the revolve command, very simple. As I mentioned before, you're selecting your revolve, selecting your sketch, your rotation axis, revolve part. The key thing there is, of course, sketching that revolve profile that you want to rotate around. The next thing I want to mention is the sweep command, and let's get into how to create something like a sweep. A good example of a sweep would be like a U-bolt, where you want to sweep a profile along a path, and that's what's going to define your shape. A U-bolt is a very simple example where I'm sweeping a circle along a U-shaped path, but it's a great example if you're just getting started with the sweep command. So let's get into it. Now, in this example, I'm going to start on the front plane again. And in general, one big tip that I'd have, not for all, but in many situations, for a sweep, you want to start with the path, right? And then attach your profile to that path. And in my example, I'm starting with nothing, so I need to construct both profile and path. There are some scenarios where you may reference edges of your part for a path, or you may, so just realize it's not all scenarios, but most scenarios you want to start with the path for your sweep. And so that's what I'm going to do. Now, the path for a U-bolt is a U-shaped sketch, right? So I can start with a line. Right? Then we'll do a tangent arc. Right? And then another line. Now, I want to make sure I have tangency between the line and the arc. So I'll left click, and make sure that they are tangent. There we go. Then I'll add a few dimensions. Right? So let's say 1.5 and 1.5. Okay. So now I have a fully defined sketch. Now keep in mind, this is only one piece of our sweep. Remember, a sweep requires two things. It requires a path, and that's what we've done here, but it also requires a profile that you sweep along that path, right? So if I hit the green check, I'm accepting this sketch. I'm done with this sketch. Now I need to create a new sketch to sketch my profile, right? As I mentioned before, two of them. So one big tip that I have, if you've sketched your path like I've done here, you may run into a scenario where you don't have a plane to sketch your profile on. What I mean by that is, in general, with a sweep, you'd want your profile right on the end of the path, literally attached to it, using a coincident or a Pierce constraint. But there may be times when you don't have a plane there. So one big tip that I have that's especially useful for the sweep command is inserting what we call a curve point plane. Oftentimes you need to insert a plane at the end of your path, right? So if I choose my curve, the end point of my curve in my path here, I get a plane that's normal to that endpoint. So this is especially important in the sweep command. It just so happens in the example I'm giving you, in this very simple example, there's a default plane right there. because that's I ended it at my origin. I would say the majority of the time when you're creating a sweep, you're probably going to need to insert a plane at the end of your path, like I've done here. So curve point, choose the path, the end point of the path, and you'll get a plane normal to that end point, right? So that's a big one, a big tip that I have for the sweep command. I would say the majority of times that's a necessity. That's something you really need to do. All right, so now we can start our sketch on that plane and sketch our profile. Now, as I mentioned before, with a U-bolt, like our example, the profile is really just a simple circle. So let's say we want a 0.25 circle. Now, one very important thing, this is probably one of the biggest tips that I have for the sweep command, is the profile must be attached to the path in some way. And what I mean by attached is it must be constrained. You have to create some kind of constraint, either coincident or pierce. I can't just leave this floating out in space. I need to attach it to the end of my path here. Now, in this example, it's very easy for me to just left-click the point, and make the two coincident. Coincident, as I mentioned, is one of the ways that you can do that. Now, you may not have a point here. What if this line continued on for a long period, or what if it was, some other scenario where I wanted to attach the point to the line? That's where you would use the pierce constraint, right? Where this line pierces the current sketch plane, it will attach your point. So just realize the coincident or the pierce constraint are necessary in order to attach your profile to your path. So in this case, left click, we'll choose coincident. Right. So now my profile is attached to my path. I'm ready to create my sweep. Right. So I can hit the green check. Now I have two pieces of my sweep, my profile and my path, and I'm ready to move on. We'll go to the sweep command. First thing to choose is your profile, or the face or sketch region that you want to sweep, in this case just the circle. Then choose the path. Now, one big tip that I have is you can select individual pieces of a path. I can say just this one line of the sketch I want to sweep along, or I can say just the one line in the arc. But as you can imagine, if your sweep path is dozens of lines and arcs and it's all interrelated, you don't want to select them one at a time. What you can do is instead select the entire sketch from the feature list. Right? So if you have lots of lines and arcs and things like that, you don't have to select them individually from the graphics. Just select the entire sketch from the feature list. It saves you a lot of time in more complex sweeps where you have a lot of geometry. All right, so let's move on. That is a simple sweep. And again, the key thing, profile and path. So two separate pieces needed to create that sweep. So next up, let's get into the loft command. Now, the loft command is definitely one of the more time-consuming commands in Onshape. And I say that because, a sweep and a revolve, especially a revolve, one sketch, real simple, straightforward, rotate it, and you have a finished feature. A sweep's a little bit more involved. You have, two features, right? You have two sketches, a profile and a path. Lofts can be very complicated. And what I mean by that is it's really up to you to define, how complicated you want your loft. And they're potentially infinitely complicated. But the key thing here is you get the utmost control over your shape. And so if extrude, revolve, and sweep don't work, and you need a shape that you can't get with one of those tools, oftentimes loft is the command that you're going to go to next. The example I give is something like this squeegee, where you have a shape that's not easily defined using a revolve or a sweep, especially in extrude. Shapes like this aren't easily created using those commands. So what would you do? And the answer is a loft. Question: is this how you would implement tubes, pipes, and wires? And I'm assuming you're referring to the sweep command. Yes, you could sweep to create tubes or pipes, or I will say that we have special feature script features for creating wires. We have a special feature script feature for creating tubes and pipes. I believe well, maybe not pipes, forgive me, but there is a feature called beams that I would look into if you're looking to create, like weldments, for example, pieces that are being welded together. I would definitely check out the beams feature script. There's also a wiring feature in the feature script library. So yes, you can use sweeps to accomplish this all yourself. Just sketch the profile, sweep it along the path. But there are also some commands that may speed up that process even more. I would look into beams feature and the wiring feature. Will Loft allow us to create a screw? No, I would use the helix and sweep. So essentially, to create a screw, you would be sweeping a thread profile along a helix. And that's how you'd go about creating a thread, for example, or a screw. All right, so moving on, as I mentioned before, Loft Command is some refer to it as a last resort, but when you need it. It's the type of command that takes time to set up, but it will give you the utmost control over your shape. So this is a good example of a loft for a few different reasons. First, this loft it's actually two lofts. We have the handle and we have the transition. And in this example, I just want to show a real simple loft. All this is a loft between two circles. So a simple circle, you're lofting between them. And you may ask, well, you can do that with a Revolve. Why would you bother? The answer is because I could manipulate this shape using guides. So you'll notice that I also have two more sketch entities here, a spline on the top and a spline to give me those grooves for the finger that I want in my handle. So I'm manipulating the loft based on other geometry, right? It's not a simple symmetric part, so to speak, like a Revolve would be. So that's one example of a loft where you're just lofting between two circles, but the guides, these spline profiles, are what are controlling the shape. That's a simple example. Now, what is another example of a loft command? Well, one of the more common questions I get is, what if I wanted to create a transition between two shapes? Right? What if I wanted to create a transition between like a rectangle and a square, or something along those lines, where it's two dramatically different shapes? And the answer is you can use a loft to construct this. Now, one big tip that I have is, by default, if I go to select a loft, for instance, and I click on the end face here, which is just a simple circle, and I click on, let's say, this rectangle sketch, by default, you may get some what we call twist in the loft. And just realize, again, the loft command, it takes some manipulation oftentimes to get it exactly the way that you want it. But the loft command itself is relatively simple. You click on the things that you want to loft between. I want to loft from this circle to this rectangle sketch down here. I select the circle. I select the rectangle sketch. It lofts between them. Now, a commonly asked question is, can you have multiple loft profiles? Can I loft between a dozen different sketches? And the answer is yes. Imagine that you're modeling something like a boat hull, right, where it's a gradually transitioning shape from start to finish. That's an example where I may have dozens of sketches, right? Many different sketches with a guy that joins them. And, that's something that would take some time to set up. But yes, you can have as many profiles in your loft as you'd like. You can loft between as many profiles as you'd like. Make sure in the loft command to select them in order. What I mean by that is left to right, right to left, whatever the order you choose, but don't jump from the first profile to the fifth, to the second, to the seventh. You want to go 1, 2, 3, 4, left to right, or right to left. Now, that's creating a simple loft. You just select one profile, another, it lofts between them. But as I mentioned before, by default, it assumes a lot of things in the loft command. So if we take a look at this loft, you can see where it's joining the two, right? I'm going from a circle to a square, and it's not immediately clear how these should line up. What I mean by that is you may have twist, where I would rather this top point of my rectangle line up somewhere up here and not down here where it is. It's important to keep in mind when you're lofting, if you're lofting between profiles that don't have the same number of vertices, right? A circle has no vertices on the outside. a rectangle has 4, Onshape has to guess as to the transition between them. And that can become particularly cumbersome in examples like this where, it's twisting and I don't care for that, right? I don't want to see that. So how would you resolve this? There are a few techniques that I can recommend with regards to the Loft command. One of the first, and this is probably one of the easiest ways to straighten out a loft, is to, I can literally sketch a circle here, is to split your profiles up into the same number of pieces, right? So let's say that, I've got these two. I want to make concentric, right? Now, what I want to do is let's fully define this here. What I want here is I want the same number of vertices. Remember that a circle has nothing on the outside, right? No points, so to speak, but a rectangle that I'm lofting to has 4. So instead of lofting just between the circle and the rectangle, I'm going to split the circle into pieces and then loft between them. So one big tip, especially in the loft command, is you can use commands like split and split your single circle, in this example, into pieces. Now, for the sake of time, I'm not going to go through fully defining it and constraining it. What you would do, what I'd recommend, is sketching construction lines in where you want to split the circle, defining all those, and then just coming in with a split command and left-clicking where you want to split, right where those construction lines line up. So now I've got 4 pieces rather than 1 circle. And what will happen here is when I loft, it will know to line up this point to this point, this point to that point. I don't have to worry about, is it going to be, loft, is it going to be transitioning the way I want, right? So if we loft here, now you have other controls as well. So it's not just splitting the sketch up, but you can control, let's see if we do this using the right sketch. You can control the amount of loft twist that you get. Now, you may have a scenario where it still doesn't line up, and that's okay. You can always match vertices, right? Now, matching vertices, splitting sketch entities still may not give you the transition you're looking for, right? Oftentimes, if it's simple transitions, where everything's lined up perfectly, you may not have to do any of this. But what is the ultimate way, so to speak, to control the loft? And the answer is what we call guide sketches. Now, guide sketches will take you more time, but the reason they're important is you're literally saying this is the shape that I want the loft to follow, right? So here's an example where I have 4 guide sketches. You can see them here, sketch 8, 10, 9, 7 here. They're just splines. But the key thing with these splines is they're attached to each profile and path, right? Or excuse me, each profile. So if we go into, let's see, sketch 10 here, you're going to see constraints attaching them to each profile. So just a moment ago, I showed you the sweep command where we had to attach the profile to a path using coincident or pierce. The same thing applies to the loft command when you're constructing guides like this example. So here, this is just a simple spline, right, between the 2 profiles, but I've constrained the end points of the spline using a pierce or, in this example down here, a coincident constraint. Very important step if you're going to use guides. Make sure that a point on your guide is attached to each profile in your loft, right? So I have 4 guides, and now when I loft, I get something that's a lot more controllable, right? It's defined by the guides and not by arbitrary decisions made in Onshape, right? So, of course, it's going to take you more time, right? Constructing the guides is going to take you more time. But if you're looking for the utmost control over the shape, that's definitely the tool that you want to use. Now, you can see here, it's just a matter of choosing guides and then defining each of your guides in the sketch, right, in the list. Okay. Now, one really neat tip and one big tip that I have for you in this is Onshape has this really cool final functionality. So anytime that you create a sketch or a feature and then you come back to it and edit it later, you can dynamically see changes made to it. And one good example is, let's say that this looks good, but I wish this was a little bit lower or a little bit higher. And I want to make a small tweak to the shape of this loft. Normally, what a lot of users would do is they'd right-click, edit the sketch, make their change, click the green check. Oh, does it look good? No. Okay, let's go back, edit the sketch. So there's this back and forth. Edit the sketch, hit OK. What does it look like? Not right. Go back, edit the sketch. What you can do is if you edit the sketch, there's a button here called Final. If you click this, it will rebuild the model live as you make changes. Very useful in scenarios like this where I may want to grab this and pull it up and then immediately see, okay, what's the impact on the loft, right? If I grab this and pull it up, what does it look like? And I don't have to hit the green check, rebuild, wait for it to see what it looks like, right? So a big tip, and this is not specific to Loft, I just think it's very useful in the Loft command, is in sketches, in features, once you've accepted them and you go back and edit them, you'll see a button called Final, and that will rebuild everything in the document live as you make changes. Another useful thing would be, if I want to make some what if dimension changes and see it update live, and I'll have to wait to hit the green check to see if I caused a problem. So one big tip, again, use that final button in the sketch to give you a final preview of what the end result will be. Question: the guides in the loft are out of plane. How did you create them? That is not true. The guides are created on a plane, as is all sketch entities in Onshape. So the guides are created on 2 planes. You can see them right there. Right? And these planes were created just using 3 points. Right? So 1 point on the handle, 2 points on the rectangle of my loft profile. So they are created on a plane. Yes. All sketches in Onshape, of course, are created on a plane. All right, so that is the Loft command. We've actually done whole webinars on the Loft command. It's one of the more robust tools. It's one of the more complicated tools that we have in terms of modeling. So if you're looking for a really deep dive into Loft, definitely check out our YouTube channel. We've done past webinars on dedicated to the Loft command and some techniques for using it. Question: what is the difference between coincident and Pierce? It's a very good question. Now, in the examples I've given you, I had the end point, for example, of that U-bolt. I used a coincident constraint because I had the end point was right there, right? But what if that line continued on, right? Or what if I wanted to attach the center of my circle to, some point along a helix, not the end point, but just some point along a curve or a helix, for example. I wouldn't be able to use coincident, right? Because there's not a point there. It's just where the intersection of that curve passes through my sketch plane. So I will say in many situations, they both work identically. But if you don't have a end point to end point scenario like I did, you maybe have a curve passing through the plane, that's where you'll use Pierce, right? Pierce wouldn't work in that scenario where maybe you have a helix passing through the plane and you want to attach the center point to it. Many situations, they both give you the same end result, but there will be times when you're creating more complex shapes where you're not attaching it to the end of the curve, but just some point where the curve passes through the current sketch plane. And I think that's where you'll use Pierce. Forgive me for the long explanation there. Can you use a 3D sketch? There is no 3D sketch capabilities as of today inside of Onshape. We do have a feature script feature that will allow you to do something, like a 3D curve, but we don't have a dedicated 3D sketch functionality inside of Onshape today. Wouldn't Pierce then be very loose, though, somewhere on the sketch? No, the Pierce would be where that curve pierces the current sketch plane, wherever that point is. It is true that it could pierce the sketch plane in 2 places, and then it's going to solve to the closest. But ultimately, it is whatever point, that exact intersection of the curve and the current sketch plane. That's the point that is attaching the Pierce constraint to. All right, so let's get into some more features. So we've covered Sweep, Revolve, and Loft. The next thing that I want to get into is the Hole feature. Yep, so let's get into the Hole feature. Now, forgive me, I almost forgot. While we're here, one thing that I wanted to show was the ability to create a shell. Now, if you do any kind of design that requires uniform thickness, a good example would be like injection molded parts, where I really care about wall thickness for in molding's sake. Shell command is going to be a very useful command for you, where you essentially give a solid part and say, I want to make this hollow with a certain wall thickness. Right? And the example would be, as I mentioned, like injection molded parts. So very simple command. You'll see the shell command in the toolbar. Now, you can simply make a part hollow. If I wanted to just say, don't remove any faces, just make this part hollow, I can check hollow and then just click on a part, and that will make it hollow. Now, from the outside, you really don't see any difference, of course, right? Because I didn't remove any faces, but this part is now hollow. Many times, though, you may want to remove a face in the same step as the shell command. And one good example would be, in this finished squeegee, this is actually open. This is an open-ended part. This is a, uniform wall thickness throughout, and this end piece is open. So I can left-click that as a face to remove, and you can see the shell, right? This is now an open-ended piece, and there's my hollow part, right? So just keep in mind the shell command, if you're trying to create a uniform thickness throughout your part, in examples like injection molded parts, it's going to be an invaluable command. You can just make a part hollow by checking hollow and then clicking on the part. But if you want to remove faces as part of the shell command, then you'll leave that unchecked and just click on the faces that you want to remove. So that is the shell command. I know, very simple to show, but I think a very common command and something that a lot of users have asked for. Now, let's get into the next one, and that is a hole feature. Now, the hole feature is useful if you want to create a standard size hole. I want a 10 millimeter counterbore, or I want a 1/2-13 countersink, something along those lines, where I don't want to dig through, look online, dig through a manual to figure out what the tap drill diameter for a 5 millimeter hole is. I want to just say, put a hole here. Keep in mind, as I've done this, it's you have a long list of things to choose from. As we're doing this, realize that you don't have to figure out what is the counterbore size for a 10 millimeter counterbore. What's the depth of a 10 millimeter counterbore? So a lot of the hole features just automating, creating that standard size hole. Now, one thing that I want to stress is the hole feature, it requires you to add points or define by a point, an existing point. So step one in creating any hole feature is sketching the points where you want to put the holes. Right? You can see I've already got a sketch here, which is just a sketch of a series of points. Right? So I've got a few. Sketch 63, you can see here is just 3 points. It's all that's in that sketch. So step one, make sure that you go through and define all the points where you want holes. And that's just a matter of sketching points. Once you've done that, then you can use the hole feature. Right? So here's the hole feature in the toolbar. Right? Now, pretty straightforward. I would work your way from top to bottom. First off, what kind of hole do you want? Simple counterbore countersink. Let's say I want a counterbore. It's a blind hole. One thing I like to mention, blind in last. Very useful if you want to put a hole through many parts, not just one part, but several parts. You want them all to line up. You can choose blind in last. I'm just going to choose a simple blind counterbore. Here's my standard. Right? Choose custom, ANSI, or ISO. Then choose the hole type, whether I want clearance, tapped, or drilled. And then my, in this case, thread size. Right? So this is 1/4-20. Let's set this to maybe 1/2-13. Right? Now, as you're filling all this in, the details of that are going to populate down here. You can change it, as I mentioned. You can even do custom hole definitions, but that's really all it takes. Define the hole, right? So you can see I've defined all the details of the hole. Then just click on the point where you want to put the hole. And as I mentioned before, that assumes that you've already sketched it, but in this case I have. So I just left click, and it creates a hole. Right? I can see that 1/2 inch is a little too big there. So let's go to a 3/8. Right? So there's 3/8, 16. Now, This is a simple example. I'm just saying I want a 3/8 counterbore at this point, and I click the point, and it adds my counterbore, as you can see here. One thing that I want to stress, though, is you don't have to be really particular about the position of your points. And what I mean by that is, let's say that I wanted to put a hole on this surface, on this round face here. I want a hole to go through it, vertical, same orientation as this one. Well, the question often gets asked is, well, how do I put the points on that face? And the answer is you don't have to. In Onshape, it will recognize, if I click on this point out here, it will recognize that the geometry doesn't start until well below that point. And so Onshape will recognize, okay, the part doesn't start till down here. That's where I'm going to start my counterbore. So you will still have an accurate counterbore depth, even on complex surfaces like this, even when you put your point well above that point in space, right? So just keep in mind, you don't have to be super critical about putting the point exactly where the hole should start. If you want to, you certainly can, but you don't have to. Now, another thing I want to stress here is it's using the normal direction of the plane that the point was sketched on to determine the orientation of the hole. So this point was created on this flat face, and that means the normal direction is straight down, and that's how it determines the direction the hole should go. The big advantage of this is you can create a few different sketches, sketch all the points on all the different planes that you want, and then use one hole feature to do all of them. So you can see as I select this point was sketched in a plane direction that's going in the opposite way, right? So there is my hole going in the opposite direction. I can go to another point over here, for example, click, and it's going in, again, that other direction. So just keep in mind one hole feature, as long as all the holes are the same size, you can click on points in any direction that you want. And that's, of course, just keeping in mind that, it's using the normal direction of that plane that you sketched on to construct the point. And that's how it's determining the direction of the hole. But that's really it. That's the details of the hole feature. Of course, as I mentioned, make sure you've got a point. Then just click the point after you've defined what kind of hole you want. There is the ability to drill holes through multiple parts. And with multi-part studios, it's a really big, powerful feature. You don't have to manually line holes up. And then you would get that with blind in last. So just a tip, if you're doing holes through multiple parts, you want to end it in one of the parts, you can do a blind in last. All right, so that is a simple intro into the hole feature. Question, can you use one sketch in multiple hole features? Sure, yeah. And you can use multiple sketches in one hole feature. So any combination of those will work fine. Can you draw hole normal to the cone side? Yes, but it would take inserting a sketch, a plane, and then, so it would take a little bit more work. If you wanted it to be normal to the surface, you would have to construct a plane, sketch a point normal to the surface. It would take a little bit more time, but you could absolutely do it. And that's a good point. If you're sketching your points, remember when we're defining that sketch plane for your point, you're also determining the direction of the hole. So make sure that normal direction of the plane makes sense. Is there a good way to define a hole drilled through but only tapped partially on each end? If you're referring to on one end, you could do blind and last and define that. I'm not sure I totally understand by tapped on each end partially. Question, can you add space for a nut? There's no capability today to offset specifically for a nut or to define by a nut. I will say that we're definitely looking closely at that kind of functionality, but as of today, no. All right, so that's the hole feature. Let's move on. The next thing that I wanted to mention is the derived feature, and this starts to get into multi-part modeling and modeling with contextual relationships. But I think for most users out there, aside from simple parts, this is what you're going to be doing, modeling around other things. And the example I often give is, let's say that someone sent me 2 parasolid files. I got emailed 2 parasolid files, and they say you need to make a flange that joins these two, right? So I import my two parasolid files into a document. You can see this is the bottom casing. This is the top casing. These came from some other CAD system. I need to bring the two parasolid files together and model a part that joins them, so maybe a flange, for example. So the question is, and the often asked question is, how do I bring these things together and model around it? And the answer is the derived feature. So I'm going to create a new blank part. I'm going to insert the parts from the other tabs into this Part Studio with the derived feature. Right, so bottom casing, just left click. This will insert a part, this part, into my Part Studio. Right? I can do the same thing here with the top casing. And now we've inserted both parasolids that I was emailed. We've inserted them together in the same Part Studio. Now, we can also do this in the assembly level. And for the sake of time, I'm going to skip by that. We have done other webinars on in-context design. But this is the approach that you would use if you're modeling entirely in the Part Studio, right? If you want to all the relationships to remain in the Part Studio. Now that I've brought these together, it's easy for me to reference them, right? It's easy for me to start a sketch and start to sketch a few circles or whatever it is that I need to constrain this by. Just keep in mind again that I'm not, having to manually reference entities. This is imported geometry that I'm attaching my constraints to. I can even convert edges, for example, right? So if I select these edges of the holes from the imported geometry, I can convert them and extrude and real quickly put together maybe a flange that joins the two parasolids that I was emailed. So if you're doing any kind of parts around other parts, building contextual relationships between parts, derived feature is going to be very useful. Now, I would also, if you're doing a lot of this type of work, look into in-context assembly design, which we're not covering here, but we have covered in other webinars in detail. And both give you that ability to model parts around other parts, which is a very common workflow. Now, question. I think that they meant the tap drill goes through and tap from each side. I see. I think I understand in that scenario. And I think it's going to be a limitation. You can define a tap in a single direction, but I don't think you can say tap both ends of the hole. In this case, I would just put a tap drill hole through the whole thing. In derived part, what if the origins of the part do not line up nicely like in your example? And that's a very good question. I would recommend using the transform with mate connectors command. I don't have time to get into it now, but I have done a webinar on this topic. So definitely do a search for the derived feature. I walk through the workflow. In fact, I just recently did a top-down design webinar that walked through the workflow of positioning parts in the Part Studio. I'd recommend transform with mate connectors, or you can go into in-context assembly design. How did you get those casings to align correctly? That's the same question from earlier. They were modeled that way. If your parts are modeled in the correct orientation, they come in the same orientation they were modeled. Oftentimes, though, that they could be arbitrary. And in that situation, you need to use a transform. All right, so again, if you're looking for more details on positioning parts in the Part Studio, definitely take a look at webinars we've done on multi-part, on top-down design. They get into more detail on transforming and positioning parts in the Part Studio. All right, so let's move on now. I had two final things that I wanted to mention. I don't know that I'm going to have time to get through both of them, but I do want to make sure I get to patterns. Up to this point, we've discussed creating single features, but what if you wanted to take a single feature and pattern it? And we have two simple examples that I wanted to show you. We also have a curve pattern, which we won't have time to get into, but definitely worth checking out if you have the time. Let's start with a simple linear pattern, right? So let's say that I wanted to pattern this boss that you see extrude to. I want to pattern it along this part. Let's say linear pattern. I would choose feature pattern. Remember, you can choose part, face, feature, and then just choose the features that I want to pattern. And I can just left click them in the feature list here. Then choose a direction, right? Just choose an edge of the model to define your direction. Then set the number of instance counts, right? How many instances of that pattern do you want? Right? One thing to notice in Onshape is we're patterning the feature. So this feature is extruded up to next. Even as I continue patterning geometry, it recognizes that up to next needs to extend down to match the part. So you don't need to do anything special when you have scenarios like this where the pattern may alter in depth. Remember, it's patterning the feature, which, if the feature has up to next, it will recognize that in the pattern. So that's a simple linear pattern, right? You select an edge, you say pattern these features in this direction along this edge, at these distance and instance counts. Now the same thing goes for a circular pattern. So if I get into circular pattern, very simple, you'll find it just below the linear pattern in the toolbar. And again, I'm going to choose feature pattern. We're going to say I want to pattern the extrude and the fillet. Now, the key difference with a circular pattern is you need something that defines the center of rotation for your pattern. In this case, we'll just make it this circular edge. Right? So any circular edge that reflects the center that you want, just click on it, hit the green check, and there is your circular pattern. In this case, just a pattern of 4 evenly spaced instances. So that is a real quick intro, I realize, to patterns. We are out of time. I am going to stick around and answer any questions that you have. So make sure to ask any questions that you have in the GoToWebinar questions dialogue there. But I want to say thank you, everyone, for joining, and have a good day.